Hi everyone, my name is Martin Bald. I'm the community manager at Wallaroo.ai, and we are a last mile ML ops company. So we have software that gets your models into production fast, easy, and then also with the capability to make sure that they're working for you the way they're intended to. Today, we're going to talk about deploying those ML models easily to different hardware platforms. Depending on your environment, you might have different considerations that need to be taken into effect when you're deploying those AI or ML models that you've worked so hard on. And it's important to make sure that they will work in that infrastructure that you have invested in. And so you're not having to, go through hoops or obstacles to try and make that work for you. You want something that plugs right in to your existing architecture and environment. And so we'll go through that today with my colleague. But first, just let you know who we are. We had a great question a couple of weeks ago from an attendee that said, what do you guys do? So this is who we are. Like I said, we are that last mile ML production. So all that effort that you put into ideation, experimentation, testing those models, you want to get them into production super fast. And we've seen Gartner and other analysts, state from their research that around 80 to 90% of ML models and projects don't make it into production, and the ones that do, only 10% of them pay back ROI back to the organization. So that's why it's super important to have a ML production platform that works whether you're on Azure, AWS, GCP, or even on premises and at the edge, and have those capabilities regardless of what your needs are for your business, for those ML models. And the other important thing is to make sure that it plugs into your existing investments. And so, we have a lot of APIs, we have SDKs that work with the tools and investments that you've made already as well. So that's just who we are. So I'm going to hand it over to my colleague, Jason McCampbell. Jason is our chief architect at Wallaroo.ai. Jason, take it away.
Thank you, Martin.
And I'll stop sharing so you can share.
Perfect. Let's say I'll bring up my window here. And what we're looking at here is the Wallaroo dashboard. And Wallaroo's installed software we install into just about any Kubernetes environment. As Martin said, we support all the major cloud vendors. You can run it on-prem. We try to be pretty agnostic there. Similarly, our interface, browser-based, and you can connect to the Wallaroo cluster from anywhere that you can get a browser access to it. And what we're looking at here is my default workspace, a couple of pipelines, a couple of models, and I'm going to switch over to this particular workspace right here. I'm going to switch over to our Jupyter network, our Jupyter Notebook environment. Wallaroo includes this very standard, very familiar Python environment. But what I'm really going to be showing today is how we deploy models and our software development kit, our SDK. This SDK, like I said, I'm running in our Python environment, but it runs just as well in external environments that you may already be running, whether it's Databricks or Azure ML or Visual Studio Code on your laptop. The first part of what I have here is we're just going to connect to the cluster. So I connect my SSO link, and this connection just goes through our internal services, and you can maintain these list of accounts and who has access within Wallaroo, or we can federate, of course, to Azure and Google and Okta and others. So now that I'm connected, I'm going to read in an image here because I'm going to do a demonstration of deploying a computer vision model. But what I really want to demonstrate is how you can take advantages of different hardware that you may need to deploy to. Because when it comes down to deploying ML models, it's fine if you're deploying one, you can deploy to one set of machines. When you want to scale to tens or hundreds of models, you're going to need different sorts of hardware. Models are going to run more efficiently on different types of hardware. They're going to have different requirements in terms of CPU capacity and memory. Also, do you have a GPU? Do you want to deploy to x86 or ARM? This is one of the things that we can help with here. And of course, Martin, as you mentioned, we support cloud and edge, and you get an even wider variety of hardware when you start looking out at edge devices. So let me read the image in, and you'll notice the dot arrow syntax here. Our engine supports standard JSON inputs. That's sort of the lingua franca for most services. But when we start talking about images and other inference models that take large amounts of data, it can be much more efficient to put it in a binary format. And the Apache Arrow standard has become a very nice and widely adopted standard for how do we transmit data around in a binary form. So we support both of these. User's choice, which one you want to use. The important part down here is I'm going to get to the deployment config builder. And this is where we specify what resources we want to deploy our model into. In this case is what we're going to be allocating as far as Kubernetes resources. Here I'm allocating 6 CPUs for the model. I'm going to allocate an enormous 40 gigabytes of memory just because I can. And what I'm selecting is our node pool, or VMs, that are tagged as x86 large memory. Now, this model doesn't actually require 40 gigabytes, but this is a demonstration. So I go ahead and build this configuration, and I'm going to upload our ResNet 50 Onyx model. We support a wide variety of models. This is a very common open source model that we're going to use for the demo today. Now we come down here to the part where we're actually going to deploy the model. And when I say deploy it, I mean stand up our engine, running these models, and providing an HTTP interface where anybody with network access can do an HTTP post, send data in, and get the inference results back. All of our deployments include load balancing and, of course, the observability feedback so the data scientists can understand how the model is performing. That's a subject for a different day. What you can see here is we're building the pipeline. We're going to add the model step in the model that we uploaded right above, and then using the deployment configuration we defined above. So I kick this off. Now Kubernetes takes just a second, and that's an opportunity for me to grab a drink of water. Like I said, what it's doing right now is allocating the pods in Kubernetes, both our engines and the load balancer. And here we go, it's ready. I'm going to run a couple of inferences, and you can see our round trip times, and we're inferring the engine that we loaded above, and the round trip time was, in this case, 68 milliseconds. So that's great. We have a service up. We can now connect other software systems to it and start performing inferences on it. We could run a batch process where we do a database pull and start pulling all sorts of data through it and then shut it down. But x86 is a great processor, but there's also ARM processors out there, and sometimes they're often cheaper. How would the pipeline run on ARM? Well, instead of having to go through and create a new container, go through and figure out which Python packages or anything else happen to work on ARM, one of the big advantages we bring is our engine tries to abstract that away. You define the inference pipeline that you want to run, and then we take care of running it and using whatever hardware may be available. So right now I'm undeploying the pipeline, and I'm going to go up here, and I'm going to select an ARM64 16 configuration, and we'll give it 14 CPUs and cut it down to 2 gigabytes of memory. And yep, it's undeployed. So I select this deployment configuration. Now I'm going to go back down here and I'm going to deploy again. So now you notice I haven't re-uploaded the model. I haven't changed anything about what how the pipeline is built. It's the same model step, but now I'm going to deploy to a completely different processor architecture. You'll also note that I changed multiple variables here, memory, CPU count, and everything. Please don't take this as a benchmark comparison of two processor architectures. That's not the intent here. I just want to demonstrate how easy it is to switch hardware configurations from one to another. And very quickly, you can analyze how your particular models behave on these different systems and perform load testing to see which one might be more cost efficient. So we'll give it a second here. And it's just taking a second for it to come up. Unless I have a typo in it. There we go. So let's try to deploy that again and actually select the right configuration. That's one of the golden rules of doing demos is, you try not to write code or run everything live. You like to do a cooking show demonstration, but sometimes it's fun to live on the edge here, and
No pun intended.
you can see that we're doing a real live deployment.
I was going to say no pun intended when you talked about living on the edge.
Exactly. All right, so I'll show you. What I did was forget to shut down the previous one. So I'll show a feature of the SDK live here. So I can list the pipelines that we have. And you can see I have two different pipelines here, and one of them is still deployed. So I'm going to grab 0 and undeploy it so I can get some resources back. We'll give that a second. And this is because I'm running on a small demo cluster, so I have not allocated enough CPUs to have a bunch of pipelines up at a time, especially not when I'm allocating 14 CPUs piece to them. Now, one of the capabilities we have here, it's already deployed, that was quick, is we can take the same pipeline description, one model step, multiple model steps, and match it up with our engine and deploy that to an edge location as well. So in this case, we're deploying to the cloud, and that's nice and easy. But when you start talking about teams needing to scale up the number of models you support, being able to deploy to edge locations is going to be critical, because not all models can run in the comfort of the current cloud that you're running in. You may need to be running them on edge devices, on sort of fog local servers, or maybe just in a remote cloud environment, but it's still outside of your current Kubernetes environment. So anyway, this pipeline is deployed, and I'm going to run a number of inferences through, and now we're seeing, it's settled in about 55 milliseconds. So what I have done here is taken the same model, the same pipeline, and deployed it on first to an x86 environment, and now I've deployed it over into an ARM64 environment. In this case, my cluster is running on Azure ML, and it's using those ARM virtual machines. We can do the same thing with GPUs. And the whole goal of this is to isolate the hardware and the different abstractions required to access those hardware capabilities and separate those from the needs of the data scientist, which is, I just need to run my model and I need to get it up and going. And now I need to run my model and run it most efficiently, most cost efficiently, so that it can really generate ROI for my organization. Sometimes ARM may be more cost efficient, sometimes x86 may be, certainly GPUs. There's many times where a GPU is not the most cost-efficient solution, that most of your time will be overhead. That's something that we really try to address. But if you're running a large CV model or some of the very large NLP or LLM models, a GPU is going to be more cost-efficient because they can bring as much as a 10x improvement in runtime. But this is something that we really want to make it easy to experiment with, so you can understand how does your particular model run and what's the most efficient way to do it. And that's it. Are there any questions?
No questions right now, but I think the one thing that's important, that my manager, who's head of product, Yunus Amar, when I did my demo the first time, the feedback he gave to me was, when I went through the deployment, he's like, don't skip over the importance of deploying your modeling environment in under 45 seconds. I mean, it can take some organizations, days, weeks to do that. And, what you've seen here from, yourself, Jason, is it's a matter of seconds, regardless of, whether it's x86 or ARM. And so important for, the audience to hopefully appreciate that.
That's an excellent point, Martin. Yes, it's easy for me to get used to this, but that step replaces the whole process of having to go build a container image, have to take your model, wrap it with Python code, wrap it into generate the image, and then go through and do a lot of Kubernetes work, a bunch of YAML files to describe the deployment. And then, well, you don't want just one replica, you want load balancing. It has to be a service. You have to get all the rest of that set up. So that's a very good point. All of that is hidden and automated away.
Yeah. Yeah, and also, like, if folks are watching this, after the recording, if you might want to go back to our YouTube channel, because what we did 2 weeks ago is we talked about deploying to production, and using Helm charts to help you manage and those clusters in that environment. Like Jason said, you'll have YAML files with different configurations, and so encourage you to check out the Helm charts video. And we've also got a tutorial on that one as well, to sort of, you can step through that and get some hands-on in that environment. So cool. You good, Jason? Is there anything else that you want to cover?
No, I think that does it. This was kind of a deep dive into one little niche of the tool.
Yeah, short and sweet. That's what we like for this thing. So what we can do is I'll share my screen out if you want, and I'll just give folks a chance to see. So what, as we talked about, we have a free community edition. So it's for ML practitioners and data scientists and ML engineers like yourselves that want to get some hands-on and go through your own deployment, practice and build your skills in this area. There's a lot of companies looking for that skill set. There's a lot of companies looking to deploy those AI and ML models into production and drive that business success. And so that's where the community edition comes in. It's free. It doesn't expire, so you're not under pressure to get your hands on in 30 days, or you don't have to put in a credit card or anything like that. So encourage you to use that. And then you can also leverage and get hands-on with some of the tutorials that we have at docs.wallaroo.ai. And so let me just show you that quickly, because we have these tutorials here. There's a number of them for computer vision. We have edge, model insights, hot swap, shadow deploy, and other scenarios like that you might want to go through, and SDKs as well, as I mentioned before. And you can go grab the license, as I said, from the community portal page as well. So that's essentially all we wanted to sort of cover today. Big thank you to my colleague Jason. Thanks very much. I know you're at a conference and you had to find a free room, so I really appreciate you carving out the time to help go through this content.
Very happy to. Thank you for having me, Martin.
Awesome. Well, folks, have a look, go to our YouTube site. If you subscribe, you can look at the other content that we have there, and you can subscribe. We're posting regularly to help, again, help the ML practitioner community, and give us feedback. Let us know what you want to see and how we can help improve what we do here as well. Thanks. I'll see you in a couple of weeks. Take care. Bye-bye.